Hello again. Right, this is lesson 17 and it was to do with plans, elevations, congruent triangles and bearings. So first of all we do some congruent triangles, and this is proof. We've got to prove why these things are congruent, and congruent just means they are the same as each other. Yeah, so that is the same as that, but it's not the same as that. That's it. And why is that the same as that? That's what we've got to work out. So you've got different proofs, and so the first one we can deal with is number one is this, and these are not to scale at all. So 10 and 12. Now, if we have two sides and an angle, and we're comparing one with another that has the same two sides and an angle, they will be the same as each other. They will be congruent. So this is side, angle, side. So you just got to look at the two shapes and see what you can match up. So SAS. Yeah. So that's why that if you have two triangles with two sides the same and one angle the same, they will be exactly the same. They will be congruent. Another one is, let's have a look at this, is a triangle, 10, 11 and 12 per se. Yeah. Now if you have a triangle that, I know that doesn't work, but if you have a triangle that's like that, then all three sides are the same as each other. There's no way that you could draw another triangle with those three sides and make it different. It will be exactly the same every time. So side, side, side. The third one is going to be like this. We'll have a 50 down there, 70 up there, and we'll have one on the side. It doesn't matter which one it is, it's going to be the same. So this is angle, angle side. We'll put the side in the middle. It doesn't matter which way round these are, the letters, angle, side, angle. And there must be some more. There's only about 4 of these to remember. And the last one here is like this, and we've got a right angle in there, we've got the hypotenuse there, and we've got another side. So this is like side, side angle, side, side angle, side, side angle, like the top one, but this time it's a right angled triangle. And this is called right angle, hypotenuse, and side, or RHS. There you go. So that's the first little bit on congruent triangles. We'll come back to that later on as we go through exam papers, etc., etc. They can be congruent, different kinds of shapes, can't they? They don't necessarily have to be triangles, but those are the kinds of questions you get on the triangles. The next one was bearings. Only a level 2 or 3 stuff, this. Bearings. Now, what you've got to work out bearings is, imagine we've got a boat, something, yeah, and we said, oh, we want to go that direction, and so you need to steer the boat in that direction, and that's, you're given a bearing to go by. And you don't necessarily have to be in a boat, but this is the most common place you'll find bearings. And for bearings, first thing you need to do is face north. So you need to face north and then turn clockwise. So that there, say that's about 70 degrees. So that's the bearing you need to head on, so that there's no complication or possible chance that do we go 70 degrees to the right or to the left or south or north or east. Always face north, turn clockwise. So now if we've got bearing A, so you've got 2 towns, and we want to find the bearing between the two towns, and we're measuring things with protractors most of the time. So what this, now be careful here, because you can have the bearing of A to B, or the bearing of B from A. Now they're both the same thing, but they're written differently, so you've got to be careful and know that the direction that you're going. So from A to B, so we're going that way. So you face north, and then you turn clockwise round there, measure that with a protractor, so that's 60 degrees. So that equals 60 degrees. Now what about if we have the same thing but go the other way? So we've got A and we've got B, and we want to find the bearing of B to A, or A from B, either way. So you start at B, which is our source, our starting point. So this time you go from this one up to north, and you go round clockwise until you get to there, and this angle is your bearing. 180, maybe it's about 220 degrees, something like that, yeah? All the way around, measure it. Protractor won't go all the way around, so just do 180 and then measure that a little bit and add it on. That's all you need to do. So, any more complicated than that? Yes, of course there is, yes. Now, one thing you've got to know here is got to go back to a previous lesson where we had parallel lines, yeah, and this angle and this angle are called allied, and they add to 180. So that's something to bear in mind. Okay, so let's have a look at a question here. So we've got A and B, A and B. So we're going to have this north, and then the two between them, and we want to find the bearing. I'll put some information on there. Bearing of A to B. So we want this direction here. So what we're going to give you here is this, and I'll say that that is equal to 210 degrees. Okay, so north. So we want to find the other one. So first of all, everything around in a circle is 360. So if we do 360, take away the 210, we're left with 150. So that means that bit there is 150. Now we go up there to north, not very straight, doesn't matter. And we want to find this one, the bearing of A to B. Now, because these two are facing north, we can say that they are parallel. It's flat, Euclidean geometry or something. It's flat, yeah. So if that's 150 and this one will add together to make 180. So all we need to do is 180 minus 150 equals 30. So this angle here is 30, and that is our bearing of 30 degrees. That's about as difficult as it can get. So let's so let's have A and B. Okay, so there we go. So the bearing information, the bearing A to B equals, just make sure I don't get the same numbers as I got there. Nothing's to scale, we'll call it 70 degrees, yeah? Okay, what is B to A? Okay, so let's put in what we know. So there's north, and we know that that is 70. Now we can draw another north there to make our two parallel lines. So this one there with the B in is going to be 180 minus 70, which equals 110. So that angle is 110. Now the bearing from B to A is this one all the way around the outside. Remember, face north, go clockwise. So this is now going to be 360 minus 110, which is 250 degrees. 250 degrees. That's the bearing. So that was the second part of that little quiz lesson. Now the other point of this lesson was plans and elevations. Right, so let's draw a little cottage with a chimney, something like that. So we've got a 3D cottage, and we're going to draw a plan and some elevations. So what we're doing here is working out what this 3D image would look like if we were standing in various viewpoints, and so we can then transfer this 3D into some various 2D images. The plan is always looking down. This, because it's the front of the house, I'll call it the front elevation. This is the side elevation. Let's just write the word front there, because that's not very good, is it? And this is the front. Now be careful, because sometimes the side and the front get swapped around depending on the shape, so you'll have to work out what is what. And normally you would draw these on some squared paper, and you may get a scale of 1 centimeter equals 1 square or something like this. So what's this going to be? From the side, we're just going to see this, and you're going to get the chimney up there. Yeah. From the front, we're going to see the house bit there. It's not supposed to be sloped, yeah. And then on top, you get the chimney over on the left hand side, and you get the roof like that. There's no curves, there's no diagonal lines, not supposed to be. That's exactly what you would see. And from the plan, you would see the two roof bits, and you can do this either horizontally or vertically. The orientation doesn't really matter, but you would see the chimney there. Important to get that in the right place. So that's basically what we're doing, and they just give you some geometric shapes, and you have to just draw the plans and the elevations. So first geometric shape we're going to look at is sort of L-shaped, yeah. So we've got plan, we'll call that the front elevation, and we'll call this the side elevation. So the plan, we are going to see the plan, I'll do that down here. We'll see that bit at the top, and then we'll see the other flat bit there. And if these had measurements, you'd put the measurements on there so that you could draw it accurately on the scale diagram. From the side, all we're going to see is this, like that. And from the front, you would see that little bit and that little bit. So from the front, you're going to see that and the bit behind it there. That's it, yeah. So let's make the shapes a bit more complicated. See where we go. So actually, the more complicated the shape, the harder it is to draw. So we've got and imagine these are all cubes. So we've got another cube on top of there. one stuck on the side, and then there'd be another one underneath there, like that. Bit rubbish, isn't it? But never mind, let's just keep going. There's another one there, and then there's another one on the top, and like that. Okay, so we've got a stack of 4 on top of each other, and then some lots of sticky out bits. So there's the plan, there's the side, and there's the front. Okay, so what's the plan look like? So we're going to see these 2 at the top, and that one sticking out. So the plan is going to look like this. That's it. The side, we're going to see all 4 up in a row. 1, 2, 3, 4. And at the bottom we got one sticking out to the left, and at the top we've got one sticking out to the left. And the front, from here we're going to see all those 4 in a 4, those 4, and then the second one up there's one sticking out over on the right. There you go. So plan, side elevation, front elevation. You can imagine drawing them on a gridded squared piece of paper. Right, what else have we got for us? Okay, so how about like a wedge type thing? Yeah, so it's bigger at the back than it is at the middle. So I'll put some numbers on here to try and make it a little bit more realistic. Now, because this is like a regular old shape, the assumption that that's a 6. We don't need to know this one. So that's the plan. Here's the front elevation, and here's the side elevation. So the side, you're going to have an 8 at the bottom, and then up for a 4, then up for a 3. See, just join those 2 together. So that's why you don't need to know that sloping side. Right, so from the front, we're going to see this rectangle here, which is 3 by 8, and then you're going to see some of that sloping bit. Now the back is 4 high and this is 3, so there's an extra little bit on the top, which is 1. And the plan, all we're going to see is this rectangle. We're going to see a rectangle like this, and that's 6 wide and 8 deep. Yeah, these are all right. These now. Okay, so a GCSE type question that is definitely from past paper. So what we've got a cube, and the cube is 10 by 10. Yeah, so let's do it 3D. So it's going to be 10 that way as well. Now on the middle of a cube, we've got a cylinder, yeah, and the cylinder goes from the front to the back, like that, okay, and the diameter of the cylinder we'll call 3. So can we draw a plan, a side, hang on, this direction, a side elevation and a front elevation, and put all the numbers in so that it's we would be able to transfer those on the squared piece of paper. So the front elevation, we're going to see the square that is 10 by 10, and we've got that, which is going to be 3. Now that middle there, obviously because this is in the middle of this square, this could be divided up into 5, 5 to help you draw the circle, to find out where to draw the circle. The side elevation, we are going to see that side there, which is going to be 10 and 10. And on the top we see this. Now because this is diameter is 3, it's the height is also 3 as well, because that would just be the diameter the other way around. So we would only see a cylinder from edge to edge stuck on top with a height of 3. And the plan, we would see the top of the box like that, which we know is 10 by 10. And in the middle we would see our cylinder there. Now the cylinder is 3 wide, so that would be 3. If the whole width is 10, that's 7 left to share between those two bits, so that would be 3.5 and 3.5, or 3.5. Yeah, and then that would enable you to draw that all on squared paper. And that is the end of lesson 17. And